this is some information on parts of a parabola. So we have been looking at quadratic equations. That's equations with x squared in it. And we've looked a little bit at the graphs, but we're going to really take a look at some important features of these graphs. And we're going to draw two example graphs. And the reason we're going to draw two examples is because parabolas can be kind of a U shape like this, okay? And they can also be this kind of upside down U shape like this. And so it's just nice to kind of look at the different pieces on these two different graphs so we can kind of understand what those pieces look like. So the first thing we're going to look at is the Y-intercept. And this is something we've looked at before. Okay, the Y-intercept it's where the graph hits the y-axis. Okay, and if you remember, we have found the y-intercept by plugging in 0 for x. Right, so find this by plugging in 0 for x. Now on this page of notes, there's not going to be any equations. Okay, but if we did have an equation and I wanted to find the y-intercept, we would plug in 0 for x. And that's what we're gonna talk just about pictures of graphs here, and then we're gonna get into equations next. So the y-intercept, and look, see, I called this item number 1 we're gonna talk about. The y-intercept is here, right? Here's the y-axis, and here's the graph, and so they intersect right here. So I'm gonna put a 1 right here. That's 1 for the y-intercept. Over here, the y-intercept is positive, right? And it's right here, the graph is here, and the y-axis is here, and so the y-intercept is here. Okay. The next item we're going to talk about that we find on graphs is the x-intercepts. And there's generally 2. Now, sometimes there is no x-intercepts, right? Like, for example, if the graph was down here, it wouldn't touch the x-axis at all. And sometimes there's 1, like if it comes and it kind of touches the x-axis and it comes down like that, there will occasionally be just 1 x-intercept, but a lot of times what we see is we see 2 x-intercepts. And this is where the graph hits the x-axis. Okay, and like I said, generally that's 2 times. Okay, and then if you remember the way that we find these x-intercepts is we find by plugging in 0 for y. And then once we plug in 0 for y, if you remember, then we have like a whole kind of complicated equation to solve. And then these we can solve by factoring, we learned first. Or we can also solve by quadratic formula. Okay, so when we find the x-intercepts, that's where the graph hits the x-axis. So I'm going to go ahead and label my x-intercept right here is 1 point where the graph hits the x-axis. So I'm going to label it with a 2, right? And the reason I'm using 2 is because I said, okay, 2 is the number 2 x-intercepts, right? So this is an x-intercept. There's another x-intercept right here, right? There's 2 on this graph. Over here, there's also 2 x-intercepts. The graph hits the x-axis right here, and it also hits the x-axis right here. Okay, so those are the y-intercept and x-intercept. We have talked about these before. Okay, so now there's some new information. Okay, it's kind of exciting, right? Something new. So the next thing we're going to talk about on a graph is what's called the axis of symmetry. Okay, and the axis of symmetry is a line. Okay, it's a line. Oops. Not Lind, line down the middle of the graph. And so a line of symmetry is a line that cuts something in half. So when I say down the middle, I mean really, truly down the middle. Like this would be an axis of symmetry because it cuts the graph in half. If I were to fold the graph over this line, it would sort of land on top of itself. So that's what it looks like. And the equation of this line, because lines have equations on a graph, is always x equals a number. Okay, and we're going to talk more about this, but like the equation x equals 3 is actually a vertical line on the graph where x equals 3. Okay, so this is what the equation of a line of symmetry looks like. And here's something that we haven't talked about yet, and I'm not going to go into detail here, but it's going to come up in our next round of notes. We find this. We say x equals, and you've seen this before, negative b over 2a. Okay, and so you'll see more of this. Don't worry about it right now. But what you need to know for now is the axis of symmetry looks like this. So on this graph, you can see like it kind of divides in half over this line, right? Like if I were to fold the graph over that line, it would be the same on both sides. And so I'm going to label this, right? We called axis of symmetry was our third item we were discussing. So I'm going to label this line with a 3. This is the axis of symmetry. And over here, you can see the axis of symmetry would be x equals a positive number, right? It's like over here, like here, right? This might be like x equals -1 or something, right? That's kind of negative. And then here it might be x equals 3 or something like that. So this is, again, this is the axis of symmetry, right? That's the axis of symmetry. Okay, and the last point we're going to talk about is called the vertex. The vertex. Okay, and this is the point where the graph changes direction. Okay, so the axis of symmetry is a line. The vertex is a point, just like the X-intercept and the Y-intercept are points. Okay, so this is a point where the graph changes direction. What does that mean? I'll show you on the graph. Here the graph's going down, 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 and then right here, oh, now it starts going up, up, right? It changed direction right here. That right there, that is the vertex. And I'm going to label it with a 4 because I said vertex was number 4. Okay, here the vertex is right here, right? It's at the top. Right here is going up, 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 and then it stops and it starts going down, 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 down. Okay, now the vertex, right? It's the point where the graph changes directions, but you notice on one of the graphs, the graph was going down and then hit the vertex and started going up. And the other graph, it was the other way. It was going up and then it started going down. So the vertex can be a minimum. What does that mean? It means it's the bottom of the graph. So if a graph is shaped kind of this, like a U, the vertex is on the bottom of the graph. Or it can be a maximum. Sometimes the vertex is at the top of a graph, right? If the graph looks like this, then the vertex is actually at the top of the graph. Okay, and then here's something we're not going to get into right now, but how do I find the vertex? What you do is you say, okay, well, you'll notice the vertex is always on the axis of symmetry. So the x value of the vertex is actually the same as the x value for the axis of symmetry. So what we do is we just plug that value in to find the y value. Okay, we're going to talk about that later. But we're going to put it in our notes right here so it's all in one place. You find by plugging axis of symmetry value in for x. Okay, and we'll come back to that. Okay, but you should definitely have these two sketches and be able to kind of, right, like if I give you a sketch of a graph, you should be able to tell me, okay, this right here, that's the vertex. This right here, that's called the line, the axis of symmetry or line of symmetry. Axis of symmetry. This right here would be the Y-intercept, right? So you should be able to look at a graph and kind of identify these points. These two are X-intercepts. Okay, so that's where we're at right now.